Okay, Wildcats. Today we're looking at Gauss and Haus solving systems of equations. Alright, let's take a look at the warm-up. Use Desmos to solve each system of equations. So let's go into Desmos. And we're going to type in 2x plus 3y equals 8. And then we're going to type x equals -2. And the point of intersection is the solution, so we're going to click there. So the answer is x equals -2 and y equals 4. Which can be also written as the point -2, 4. Alright, let's take a look at number 2. Alright, so I'm going to X out of those and take a look at and then again I'm going to click on the point of intersection, and -0.333 is -1/3 as a fraction, so x equals -1/3 and y equals 4, which can be written as Alright, let's take a look at number 3. So our points are x equals 4, y equals 3 are our solution, which can be again written as 4, 3. Alright, go ahead and finish up the warm-up. Alright, let's take a look at the next page. Which fare is fair? You would like to take a taxi to the airport. There are two local taxi companies. Friendly Cab Company charges $2.60 plus 20 cents per 1/6 of a mile driven. Anderson Taxi Inc. charges $5 plus 10 cents per 1/6 of a mile driven. Let's first define the variables. X is the number of 1/6 miles driven, and y is the total cost of the taxi ride. Number 1. Write a system of two linear equations and two variables to represent this problem situation. Be sure to define your variables. Our first equation is y equals 0.20x plus $2.60 for Friendly Cab Company. And the second equation is y equals 0.10x plus $5, which is the Anderson Taxi Company, Inc. Alright, we're going to graph this system. And we're not going to use this graph. We're just going to go ahead and use the Desmos graph. So we're going to graph y equals Now, we don't see the point of intersection. That's okay. We're going to zoom out until we do. There it is. We're going to go ahead and click there. There we go. Just had to zoom out just to hear more. And so our solution is x equals 24. And y equals 7.4. So our solution is x equals 24, y equals 7.4, which can be written as 24, 7.4. Three, estimate the solution to the system of equations. The solution to the system equation is x equals 24, 1/6 miles driven with a total cost of y equals $7.40. Alright, go ahead and finish up that. Alright, let's take a look at the next page. 5. What does the solution mean in terms of the problem situation? The point of intersection is 24, 7.40. This means that if the distance to the airport is 24.16 miles, then the total cost will be $7.40. All right, go ahead and finish up 5. All right, go ahead and mark out 6, 7, A and B. Let's take a look at the next page. Activity 1.1, solving systems with linear and quadratic equations. A system of equations can also involve nonlinear equations such as quadratic equations. The methods for solving systems of nonlinear equations are similar to methods for solving a system of linear equations. 1. Consider the system of linear equation and a quadratic equation. Go ahead and mark out A. And let's go ahead and solve the system of equations using decimals. So let's go ahead and do that. And you want to press the home screen whenever you start a new graph. So then that's x squared all right, now you'll see here that it crosses twice, so we have 2 points that are solutions. So x equals 3, y equals 1, and x equals -1, and y equals -7. Which this can be written as 3, 1, and this can be written as -1, -7. All right. D. Oh, first, I'm sorry, mark out C, and let's go to D. Graph and label each equation of the system and identify the points of intersection. Let's go ahead and graph the points of intersection first. So 3, 1, and -1, -7. And let's go back to decimals, and you can see those points form our line, so we can go ahead and connect those. And I believe they use blue, so I'm going to go ahead and graph that line in blue on the paper. Okay. And then let's take a look at the quadratic. Now, really all we need is this vertices right here, and we'll have enough points to graph the parabola, so that's 0, -8. So let's go ahead and graph that point. And we know that our quadratic is going to go through these 3 points like so. All right, go ahead and finish up D and mark out E. And let's take a look at the next page. All right, number 2. Think about the graphs of a linear equation and a quadratic equation. Describe the different ways in which the two graphs can intersect and provide a sketch of each graph. So this is an example of one solution, this is an example of 2 solutions, and this is an example of no solution. All right, go ahead and finish up 2A and B. All right, number 3. Can a system of linear equation and a quadratic equation ever have infinitely many solutions? Explain your reasoning. No, a system of linear equations and a quadratic equation will never have infinite solutions. All right, let's take a look at 4. Using each system of equations in 2 variables using decimals. All right, so let's go ahead and do that. All right, you'll see here it has 2 solutions. So we have here and here. All right, so we have x equals -3 and y equals -7, which can be written as the point -3, -7. And x equals 2, y equals 8, which can be written as the point 2, 8. All right, so let's go ahead and graph the points of intersection first. So -3, -7, 2, 8. And that forms our first line. All right, and then really all we need is the vertices right here to draw the quadratic, which is 1, 9. So 1, 9. And then we know that these points will connect like so. All right, go ahead and finish up 4a. All right, let's take a look at the next page. The student will use Desmos to solve 4b and 4c. All right, let's take a look at the next page. Number 5. Simon and his sister are playing a guessing game. Simon tells his sister that he is thinking of two positive numbers. The first number minus the second number is 15. The square of the first number minus 20 times the second number is equal to 300. So first, let's go ahead and define our variables. So x equals the first number, y equals the second number. 5a. Write a system of one linear and one quadratic equations represents two numbers. Be sure to define your variables. So the first equation is x minus y equals 15, and the second equation is x squared minus 20y equals 300. And I'm going to underline in blue that's this equation on this line, and this sentence forms this quadratic in this equation. All right, let's go ahead and graph those to find the solution. I need to zoom out just a hair, and there's our points. All right. So we have x equals 0, y equals -15. So that's the point 0, -15. And x equals 20, y equals 5, which is the point 20, 5. Now, if you go back here, it says right here that two positive numbers is what it needs to be. So this solution is invalid because of the -15. So this is our valid solution. So the first number Simon is thinking of is 20, and the second number Simon is thinking of is 5. Go ahead and finish it up, and have a wonderful Wildcat day.